Hey grade 9s, alright, let's do this next lesson about inscribed angles and quadrilaterals. So, we just looked at inscribed angles in lesson 3, and that's talking about when we have an angle that has the vertex on the circumference of the circle instead of in the center. And today we're going to extend that knowledge to when we have more than one inscribed angle. Okay, so sometimes we have multiple inscribed angles that open in opposite directions. Okay, so for example, we have one angle here, and we have another angle here, and you see how they're opening in opposite directions? That's what I'm talking about. Okay, and we can also see that both of these angles intercept the circumference of the circle at the same spot. So I mean that there's an intersection here and here where both angles are meeting the circle. Okay, so in this kind of case, you can see that a quadrilateral is formed. Remember that a quadrilateral is just a four-sided shape that isn't necessarily a square or a rectangle, but it has four corners, just like a square or a rectangle. And that's what's happening here. Okay, each vertex of this quadrilateral is on the circumference of the circle. Okay, so that means that every place that intercepts the circle is one of the corners of the quadrilateral. Okay, that is what we're seeing here as well. And because it's inside a circle, we call it a cyclic quadrilateral. Okay, so that's like the official math name for this. All right, let's move down the page a little bit. So using our knowledge about arcs and inscribed angles, we can see that our angle ABC. Okay, so I'm going to do a little bit of erasing on here. It's getting a little busy, so just to clear this up, hold on. There we go. Okay, so we can see that angle ABC, that's here, and angle ADC, that's here, are inscribed, and that the measure of their arcs, I made a typo here, you guys, I'm very sorry. Okay, the measure of their arcs add up to, not to 180, they add up to 360 degrees. How do we know that? It's because they like together they make a circle, right? Like their arcs make a circle. So I've highlighted angle ABC's arc in orange, that's here, right? And angle ADC's arc in red, that's here. And those together make a circle, and so we know that's going to be 360 degrees. Okay, so knowing that, then we are going to talk a little bit as well here quickly about what that means for the angles inside the quadrilateral, pardon me. Okay, so we know that the measure of arc ABC, okay, so keep note of the signs here. I'm talking about the arc ABC, okay, not the angle, the arc. We know that it is equal to 2 times the measure of angle. Okay, now we're talking about an angle, not an arc, so that's why I'm being very careful to say these things correctly, okay, of angle ADC. Okay, and we know that the measure of arc ADC, again, now I'm talking about the arc, okay, the part of the circle, is equal to 2 times the measure of angle ABC. Okay, so essentially, what's all this fancy gobbledygook? What did I just tell you guys? I just told you that, let me find some corresponding colors, hold on, there we go. This arc here in red is twice as big as this angle. Okay, and I also told you that this arc here in orange is twice as big as this angle, and that's from last lesson. Okay, and so based on that, then we know that if we added up angle ADC and angle ABC, let's see if I can write that, sorry, there we go, then it's going to have to be half of the measure of the arcs together, right? So if we're saying that each angle is half the measure of the arc, that's what we just said in the previous 2 lines, that's what I explained when I highlighted in red and orange, then we know that also when you add up the angles together, they're going to have to equal half of the circle, and half of a circle is 180 degrees. Okay, oops, sorry. That is probably the most confusing thing I'm going to say today. So if you have an issue with that, you can definitely message me. But if you don't really care about the explanation of why this works, that's okay too, as long as you know that this is a true statement. And then we're good to go. And the true statement that I'm saying is that the two angles put together. So if you, there we go, added up this angle and this angle, it will equal 180. That's the key takeaway. If you know that, we're good to go. Okay, moving on. So the rule that I just said, that they add up to 180, is written here. Okay, the sum of opposite angles in a cyclic quadrilateral are supplementary, which means they add up to 180. This is important. Okay, so that's the thing that you need to know. I'm going to try and highlight that a little bit more clearly. There we go. Good. Okay, so that's what we want to know out of this. So using that, then I'm going to switch some colors here. We're seeing angle here is equal to 120. Okay, and then we want to figure out what is the other side. Okay, and so we know that 120 plus angle XWZ is equal to 180 degrees together. Okay, and that's the rule we just learned. So when I subtract 180 degrees from both sides, then I know that the angle XWZ is equal to 60 degrees. All right, moving down. We're going to look at the measurement here again of WXY. Okay, so we're looking here. We want to find this measure, and we already have this one, 69 degrees. And again, we know that if I added 69 degrees plus angle WXY, it's going to equal 180 degrees together. How do I know that? That's because this angle and this angle are opposites in a cyclic quadrilateral, right? So a cyclic meaning inside a circle, quadrilateral meaning four-sided shape. We have that present, and this angle are opposite. That means they add up to 180. Okay, so again, I'm going to subtract 69 degrees from both sides, and we're going to find out that angle WXY is equal to 180 minus 69. Okay, again, I know I said this last video, if you can do this without your calculator, that's great. That's preferable because your calculator use is going to go down in grade 10 and 11 and 12 from this year. But if you still need it to check your work, that's okay. Okay? All right. So I'm actually going to skip. Oh, no, sorry. My bad. Forget I said that, guys. Sorry. My mistake. Okay, we're going to find the the measure of arc LKJ. Okay, so what we're finding is this arc. We want to figure out how many degrees is that. Okay, now this question, while it might look like a cyclic quadrilateral question, it really actually is just like last lesson on inscribed angles. Okay, the reason that I included it in this lesson is because it does have a quadrilateral in the circle, right? We can see this four-sided shape there, but we can also see that this angle here, we need this to be a little thicker, hold on. This angle here, okay, is 87 degrees, and that angle corresponds with exactly the arc that we're looking for. Okay, so that is very handy because that means then we can say that arc LKJ, it's a bad arc, I'm going to redraw that. There we go. Arc LKJ is equal to 2 times angle LBJ, and we know that angle LBJ is 87 degrees. Okay, now, again, how do I know that? It's because I can see that we have an inscribed angle, and it's opening up to an arc, and we know that the inscribed angle is going to have half the measure of the central angle, and therefore half the measure of the arc. Okay, so then when I have 2 times 87 degrees, that's going to give me 174 degrees. Now, if you want to do a quick logic check, does that make sense? Then we can take a look and see here that 174 is very close to half a circle, right? It's like almost half a circle. You can also see that this arc here, LKJ, that looks pretty close to half a circle. It might be a little bit less. We can't tell exactly. The diagrams aren't to scale, but it does make sense that we would have a measurement that is close to half a circle, and so we know that our answer makes sense. Okay, now here's the one I'm going to skip. Okay, I'm going to do this example last, so just hold on for that. I should have put them in a different order, but I didn't realize. This example is actually the hardest one of the lesson. I want to do it last because of that. Okay, the next thing I want to do is this example, then we'll go back. So in this case, we want to find angle question mark. Okay, and we're going to find angle question mark by, again, using this rule. Okay, we know that this is the arc that goes along with this inscribed angle. And so if we know the arc measurement, which we can find out because we have some information, then we can find the angle measurement because we know that the arc will be twice as big as the angle. Okay, so we know that arc VWX is equal to 92 plus 120. Okay, how do I know that? I'm just seeing here that I have an an arc measurement and another arc measurement, and I can put those together to get the total arc measurement. Okay, so 92 plus 120 is going to give me 212 degrees. Okay, and when I know that, then I can figure out angle question mark because it's the inscribed angle that goes along with the arc, and therefore it's half of arc VWX. Okay, so in this case, that means half of 212 degrees. So we're going to divide 212 degrees by 2. Okay, okay, let's go up to the side here. So that gives me 106 degrees, but I want to make that look a little bit nicer. Okay, so I'm just going to write like kind of a final answer here. Now, the other way I could have written that, okay, is I could have said 2 times angle question mark is equal to arc VWX. Then I would have divided both sides by 2, but you will see we get the same answer. Okay, so both of those methods are fine. All right, let's do this last example. I'm going to zoom in a little bit so we don't have the distraction of all my other writing as much anyways. Okay, let's choose a nicer color. I don't even know, guys. There are too many colors on here. It's hard to decide. Let's do this pink. Cool. I'm probably actually going to use a few colors in this example to highlight some stuff. So if you want to have some highlighters for this example for your notes, it might be helpful, but up to you. Okay, so ultimately our point here is to find angle question mark, right? We're saying we want to know how big is that angle. And I'm going to point out here that it's going to take a couple steps to get there in this case, okay? So it's not going to just be quite as easy. We're going to have to use a little bit more knowledge than normal. So first thing I want to do is figure out that angle question mark is this angle, and therefore, let's get a highlighter to highlight along with it. We are going to see that, there we go, this arc, I'm being very careful to highlight carefully here, okay, like I want to be precise, goes along with that, okay, so we need to figure out the measure of that arc to find out the measure of this, okay. I will also point out that people do have different methods than me, okay, so if you figure out a different method to do this question and you want to run it by me, you're more than welcome to. This is not the only way to do this question, but it will work, okay. All right, so we need to find out the measure of that arc, and what we don't have in this is this part, right? We don't have this part of the arc. We have already this part, okay? So we need to focus on finding that x there in order to solve the question. So let's look and see what we know, okay? So this is where my colors are going to come into play. So I know that this is 66 degrees, which means that the inscribed angle here is 66 degrees, which means that its corresponding arc, let me just get some purple, hold on, which is here, okay, is equal to twice that, right? So we know that we can find that arc measure by multiplying 66 by 2, okay? So I'm just going to make sure I'm doing this right, because my brain is having a brain fart, see what I mean? Happens to all of us, okay? That means that this is all 132 degrees, okay? And that means that this little piece here from F to V is 132 minus what we already know, which is 48. Okay, so I'm going to write this on the side, that arc FV is equal to 132 minus 48 degrees. And so when I take 132 and I subtract 48, then we can find the measure that we're looking for, FV, which is 84. Okay, so now I know that this is 84 degrees. That doesn't look like a 4. I'm sorry. Redraw that. There we go. Okay, now going from there, then we also know that this is 78. Okay, and so yes, this all does matter, you guys. I am getting to the end of this question, don't worry. I know it seems a little crazy right now, but you'll see where I'm going. Okay, so if this whole thing, this is 78, then what we've found out is every part, I'm going to use a different color to show you what I mean. We found out all of the rest of the circle except for the part that we're looking for. So that's awesome. Okay, the reason that that's awesome is because now we have enough information to find arc ED. And the reason we know that is because if we take all of the little pieces of the circle, so arc ED, and then arc DV, and then arc VF or FV, remember it doesn't matter which order you write those letters in, okay, so this and this are the same thing. Maybe I'll just write them the same way so we know for sure. And arc EF, okay, that's here, right? And, that's all of them, right? That's all the 4 pieces of the circle. We have this arc, plus this arc, plus this arc, plus this arc. All 4 of those together are equal to 360 degrees. Now, the great thing is that we actually know how big most of these are. Pardon me. We know that arc ED is the one we're looking for, so we don't know what it is. So that's our X. Okay. We know that arc DV is 48 degrees. We know that arc FV, we just solved up here, is 84 degrees. And we know that arc EF, which is also given, is right here, is equal to 78 degrees. Okay, so when I do 48 plus 84 plus 78, I'm doing this in my calculator, it's okay if you are too, that gives me X plus 210 degrees is equal to 360. So when I subtract 210 from both sides, I get that X is equal to 150 degrees. Okay. Now, why do I care that X is 150 degrees? Well, remember that X is our pink arc here, right? That I'm also outlining in green right now. And it is the arc that goes, it helps us to find the whole arc that goes along with our inscribed angle that we are looking for. Angle question mark, which was the whole point of the question. Okay, let's zoom in again. I need to leave a little more space. Okay, so now what am I going to do with all this information? I am going to use the stuff we just found, arc X plus arc DV, or 48 degrees that we already had, to find the total of this whole arc. Once I have the total of this whole arc, then I can use it to find the inscribed angle by dividing it in 2. Okay, so I'm going to go back to pink because that's relevant now. Okay, so we know that arc ED plus arc DV is equal to 150 plus 48. Okay, so that gives me 198 degrees. And we know that arc EDV, okay, I'm going to scroll back over here, EDV, this whole arc, is equal to 2 times angle question mark, which is the one that we wanted this whole time. So when I take 198 degrees, then I can divide both sides by 2. Sorry about this getting really squishy here, you guys, my bad. That means that angle question mark is equal to 99 degrees, and that's our final answer. Okay, like I said, I know that one's a lot of work, but I hope that it is helpful for you to see me write it all out. If you have questions about anything like this, please let me know. And there is a worksheet that goes along with this before we go on to tangents with circles. Okay, I hope you guys are having a great day.